Welcome to my presentation on gender bias in STEM at the K-12 level and the media specialist's role in helping the admin team and the STEM teachers develop an action plan to combat this existing bias and hopefully extinguish it from the STEM classroom and from the general school culture. This presentation will offer a discussion of 3 current research studies that prove the existence and the prevalence of gender bias in STEM content fields. Additionally, I present an action plan to help media specialists and curriculum specialists and instructional specialists and teachers combat this bias. Students aren't acquiring the necessary knowledge and skills, it's because schools aren't teaching them. I strongly believe that anything that we are seeing as far as deficiencies for females in STEM can be addressed and corrected at the K-12 level simply by going in and changing our curriculum and changing our methods of teaching in order to make sure that we remove this bias from the classroom for female students. So how do we make sure females acquire the necessary knowledge and skills in the STEM classroom? This is what we address in the action plan and the steps that we need to take to make sure that not only do they receive the necessary knowledge and skills while they are in the STEM classroom, but that these skills are transferable to college and the workforce. And, in general, as they live in a world where they are greatly outnumbered by men in the STEM workforce. Several research studies show that science education and other STEM fields by proxy and media literacy are mutually dependent in any 21st century classroom. It's important for the media specialist to develop lessons and recommend tools and strategies that will help teachers show the ways in which science is connected to their students' lives. If students cannot see that science is going to be relevant to them in the future, in a career path or in college, they're probably not going to be interested in it. And this is especially true for females. So by integrating media literacy across the curriculum, the library media specialist can provide the means by which all female students feel included in the STEM content, and she makes it accessible and relevant to their lives. The American Association of School Librarians Handbook has, several different roles and responsibilities that media specialists will take on as they work in the K-12 setting. And one of those roles is program administrator. And another role that is pertinent to this presentation is information specialist. So she's an important stakeholder in planning and facilitating the action plan that we will introduce at the end of the presentation. And that's because in the program administrator role, she must make sure that all members of the learning community have access to resources that meet their needs. We can't just have a library collection that is geared to males who like football or 5th graders who like poetry. We have to make sure that we are including all groups, all stakeholders. And if there's a deficiency in the collection as far as STEM related materials that girls find appealing, then it's her responsibility to go in and find some web resources or purchase some new resources for the collection that will fill in those gaps and make sure that girls feel more included. And as the information specialist, the media specialist needs to make sure that she's able to recommend instructional technology tools by which to facilitate the meaningful curriculum for any given action plan. So in this particular action plan, the media specialist needs to know what instructional technology tools will make STEM content more accessible to female students. So she's a very important stakeholder in this process. According to the U.S. Department of Commerce's latest study on women in STEM, a key factor contributing and proliferating the gender bias is a lack of female role models. Now, why is that? Well, it could be that it's because even though women comprise 48% of the entire US workforce, they still only comprise 24% of the STEM workforce. So it's very hard to find female role models when women are underrepresented in STEM. Female students in STEM have a different set of needs and perceptions regarding their relationship with the STEM content. And that may be the reason why we continue to see women underrepresented in the STEM workforce. And that's what these research articles will address. The following research studies will be discussed to help teachers understand and address female students' needs and perceptions. We're going to have Gaspard, Master, and Miller, and I have the full references for these studies on the final page of this presentation, and I've also attached the paper if you are interested in going into more detail. The first study focused on math, the value beliefs and gender norms associated with female students versus male students and their feelings about math. And this was a study conducted of 9th graders. And the results of the study indicated that girls on average had higher costs associated with math, including emotional cost and opportunity cost. Girls perceived math as personally unimportant and unrelated to their future plans. This research is very important because it proves that female students who are around the age of 14 and 15, 9th grade level, these students have experienced a greater set of emotional costs related to their attitude toward math. And we can just use our brains and figure out here that this probably is the same across all STEM fields, okay? When the female student answers, "Doing math makes me really nervous," she's indicating that the classroom environment may be responsible for her nervousness or her lack of confidence. If she's uncomfortable in the classroom, that's something we can control. Teachers can control the conditions for learning. And an uncomfortable female student might not have as much intrinsic value on the subject of math since it evokes such a negative and uncomfortable emotion. This is something that the K-12 classroom needs to be aware of and address, and we can make the curriculum and the classroom environment less intimidating and more inclusive for female students simply by making a few key changes. And the media specialist can really lead this initiative to make female students feel more included just by recommending changes in the learning environment. The conclusions we can draw from the Gaspard study are that girls on average fail to see a connection between math instruction and a future career path. That's a big problem. And it could be because there is such a lack of female role models in math. We need to do a better job finding books and finding web resources that highlight female contributions to the field of mathematics. We need to do a better job letting girls see career paths where females can shine in math. Okay, another conclusion is that utility value was higher for females than males, meaning if we can just show them how their lives can improve by it, or a future career path for it, then we're going to have a greater likelihood of female students having a more positive relationship with math. A third conclusion is that teachers need to treat females and males differently as far as their value beliefs, okay? Because they have different costs and different value beliefs about what math means to them. In order to motivate female students, we're going to have to treat them a little differently. Teachers need to connect with female students by making the mathematics content more relevant to real life. And this is where the media specialist can come in and offer resources to help girls see the value of mathematics and introduce them to successful female mathematicians and females working in engineering and other fields where math is necessary, so that they will, get that utility value component. They will understand that, yes, this is important and will lead to something of value in the future. So this is a very important study, and that's why I wanted to include it in this discussion. The second study, the Miller study, was a larger study. It had a sample of 350,000 people across 66 nations, and I included this because the questions asked were a series of gender science stereotype questions, and the results overwhelmingly showed that respondents associated science fields with men more than women. It was very disheartening to read that only 35% of children drew a picture of a female scientist in a 2009 study that was quoted in this Miller study. But it was encouraging to find out that this number is up from 6% in a study 40 years prior. So that means that in the year 1969, 94% of all children surveyed drew a picture of a male scientist, and 6% in 1969 drew a picture of a female scientist. So 40 years later, in 2009, 65% of children drew a male scientist and 35% drew a female scientist. That is a large gain, but we can see that a huge gender gap still exists. The Miller study is important because it shows us that the biggest problem facing STEM educators is that gender bias is not contained to a classroom or to a school, but it is embedded into the global culture. One of the things the authors of this study suggested is that we can integrate discussions of female scientists into classroom instruction to motivate girls to think long-term about their relationship with STEM. They didn't really offer any, step-by-step plan to help make STEM more accessible to girls, but they did say that we do need to talk more about female scientists in our classroom instruction. The study also mentioned that social policy change may be in order. And they suggested that stereotypes in STEM may be weakened by increasing the diversity of student populations within the STEM fields of study. We need to attract a more diverse audience. Think about if you have a mathletes team or a science bowl team. We need to make sure that we're including girls in these opportunities. We need to make sure that we're reaching out to them and making the content less stereotypical, and making the act of participating in these STEM-based activities less stereotypical and more inclusive to females, and for that matter, all minorities. The third study examined the stereotypes that may undercut female students' sense of belonging in the computer science classroom and eventually in the computer science career field. The authors found that computer scientists are stereotyped in American society. We know that. We've all heard the computer nerd, computer geek stereotype for many years now. We know that not only are computer scientists stereotyped as being predominantly male, they are also thought of as being socially awkward. So just think about where a female at the middle school and high school ages and in the stages of development, and how much pressure there is to fit in socially. So it's going to be especially difficult for a female student to succeed in a learning environment that is full of stereotypes that have bias against females. So we need to make sure as teachers that we are aware of this so that we can adjust our environment and make our female students feel like they belong in it. This study conducted two separate experiments on high school students. The first experiment involved students in 9th through 12th grade from a public and a private school who were tested by looking at two different computer science classroom scenarios with different variables. One of these classrooms contained stereotypical elements, and the students had to choose which classroom most appealed to them and then answer a series of questions as to why they chose the scenario that they chose. Things like utility value, belonging as a mediator, and negative ability stereotypes were tested in this experiment. The results indicated that a significant gender difference existed in the choices that girls made as opposed to the choices that boys made in the classroom model that best suited them. Girls chose the non-stereotypical classroom at a higher rate than boys. They felt a greater degree of belonging in the non-stereotypical classroom than boys. And they were also, and this is the most important part of this study, they were more likely to express interest in taking a computer science course when stereotypes were removed from the classroom. This is all attributed to their need for belonging in the environment. So you see how females and males may be able to learn the same content in the same classroom, but they have different motivating factors. Females have a different set of needs and perceptions that need to be addressed, not just in the computer science classroom, but in all classrooms. The master study is important because it communicates that we can influence belonging for female students simply by making our classrooms more friendly and devoid of stereotypes. And I think that computer science is such an important course. I hope that it will eventually become a required course in the Alabama State curriculum because it's so important for future career paths. So this is something to think about moving forward, that if there's a stereotype in a classroom, it could be part of the school culture, or it could simply be part of the one classroom. But the whole school needs to be aware of how impactful these biases and stereotypes are on female students. And since teachers can control the conditions for learning, we control our classroom environment, we can control the variables at play in the environment. This is an important study to reference because it seems to me that if this is going to help females feel a greater sense of belonging, and if it's going to increase the likelihood of them taking a computer science course, then we should certainly do our best to make sure that our classrooms and all parts of the school are devoid of these stereotypes that could possibly prevent them from taking a course. So now that we know what the research says, we can start developing our action plan to address the gender bias. Ross has provided ample evidence suggesting that media specialists set the tone for curriculum development in the school. And that's because the Media Center is the hub of the school. It's because the media specialist serves all students and all teachers in the school. So if we are working to make a positive change to the school culture, it just makes sense to let the media specialist be on the leadership team, especially in the training of teachers in using some of these new technology tools to combat the bias in the STEM classroom. The media specialist's attitude towards STEM could make or break the curriculum. It could make or break the initiative to combat the bias. Media specialists, therefore, need to be aware of the prevalence of gender bias in STEM so that we can be prepared to offer teachers and offer the admin team standards-based solutions to the problem. We need to focus on what is possible in the present and what is possible in the future, meaning we should have resources prepared. We should have a list of web resources. We should have a list of web tools. We should constantly update these lists to make sure that we are engaging our students and making the content relevant. We need to make sure we are keeping our resources up to date because the goal is to prepare our students for success in careers in the future. So when we keep our eyes on what's possible both in the present and the future, it kind of puts in perspective how important it is for the media specialist to play an active role in helping the school develop an action plan to combat the bias, remembering that sometimes the library is the only place at school where some students feel at home. We know that this is true. We know that the library needs to be an inclusive place, and by making the Media Center an inclusive space, the media specialist is able to help other teachers make their spaces inclusive as well. And that's the most important part of the action plan, is making sure that the whole school is on board with what we're doing. The ultimate goal is to close the gender gap and increase the number of women employed in STEM. And the action plan that follows has strategies, diversity and planning, emerging technologies, accommodations, modifications, and evaluation of student learning. This is just a way to start thinking about how to address the deficiencies in the curriculum. And I think any good action plan always starts with strategies. I have a list of 14 strategies, and I'm not going to read them out loud. You can go through and read them, but just in general, the strategies are a product of what research says we need to be doing. And that's why I included those 3 research studies, and that's why we have an action plan that is standards-based and research-based. And we know that this action plan will be effective because it is aligned with what research says is going on. This is just more strategies continued, and I have this in the paper itself if you would like to print this out. In these 2 sections of the action plan, I really relied on the research from the articles to guide me in developing these objectives. It's clear that the media specialist needs to take the lead on this because it requires a lot of front loading, a lot of planning to develop the list of web resources and library resources and instructional technology tools to use in the STEM classroom to prepare for the school year. So the media specialist will do a lot of legwork in the beginning, and then hopefully it will be easier for the STEM classroom teachers to facilitate the learning environment because she has done so much preliminary work. And these 2 sections are very important in implementing the plan. I'm not going to read them out loud, but you can read through them and read through the paper and see how it's connected to the research. And this is the last part of our action plan. We, of course, will provide accommodations and modifications as needed. And the measuring student success section is important because I believe that student feedback is what will make this action plan effective. Students need formative assessments first of all so that we can gather information on their needs. The first step would actually be surveying them to make sure that we are providing opportunities that meet their needs in an environment that meets their needs. We need to periodically assess them and to make sure that we're offering all types of conferencing and follow-up opportunities, and making sure that their voices are heard is basically what we intend to do with this section, because if they feel like they're valued and they feel like we're actively trying to include them and make the content more accessible to them, then this action plan is going to be successful. Here is the list of references I used to write the paper and to create this presentation. If you have any questions, feel free to email me. Thank you for taking the time to watch this presentation, and I hope you will find the information helpful moving forward.